Hello, 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 and a warm welcome once again to Nestor's Bioacademy. And in today's lesson, we are going to review support and movement in animals. And specifically, we are going to start our discussions by looking at the axial skeleton in mammals. Remember, so the objective of this lesson will be to take us through the main types of skeleton in mammals. That is the axial and the appendicular skeletons. And then we are going to describe the features and adaptations of the axial skeleton bones. Remember previously, in the previous video, we looked at the various types of skeletons in which we learned of three main types of skeletons: the exoskeleton, the endoskeleton, and the hydrostatic skeleton. We described the importance of these skeletons, and we described the limitations of each and every one of them. It might also be vital for you to try and reflect upon the advantages of exoskeleton over endoskeleton. That is, like, being that the exoskeleton offers increased protection compared to the endoskeleton. And also, of course, being that the exoskeleton minimizes water loss, something that the endoskeleton doesn't do. In contrast, the endoskeleton also becomes very important because it allows growth. It's made up of living tissues, so it allows growth as compared to the exoskeleton, which was limiting growth. And also remember, the bones, which are making the components of endoskeleton, also become very important in acting as reservoirs for mineral ions, as well as production of the various red blood cells that you know. Remember, the bones making up the endoskeleton are very, very important because let's not imagine what life would be without the bones in us. We would just be some large heap of flesh there. The bones are very, very important because they give the organisms their definite shape, and they provide the organisms with the necessary support they require for them to be able to carry their weight along and achieve various life-sustaining processes. Now, in mammals, support is always brought about by the coordination between muscles and skeleton. And the skeleton is always divided into two main categories. We have what we refer to as the axial skeleton, and we have the appendicular skeleton. What's the difference between these two? If we can have a look at this, this is what makes up the axial skeleton. The bones of the skull, the bones making up the rib cage. We have these column of bones, what we refer to as the vertebral column, all running all the way down here. So the skull, the rib cage, and the sternum at the front, and together with this column of bones, what we call the vertebral column, makes up the axial skeleton. Then we have these other bones which are like attachments. They are bones which are attached to the axial skeleton. These bones which are attached to the axial skeleton excluded, as you can see in this illustration here, these bones are making up what we refer to as the appendicular skeleton. Remember, our bodies as human beings, we have a total of around 208 bones. These are split into the two categories. We are having the axial skeleton made up of the vertebral column, as we have just talked about, the skull. We have the rib cage made up of the ribs and the sternum, and of course the vertebral column to the back. And the vertebral column is always made up of several short bones, as we are going to discuss in a short while. In the contrast, appendicular skeleton is made up of the bones of the forelimb and the bones of the hind limb, together with the various girdles that attach them to the axial skeleton. So in this lesson, specifically, I want us to go through the axial skeleton. Now, as we have just established, the axial skeleton is made up of the skull, it's made up of the rib cage, it's made up of the sternum, and it's made up of the vertebral column. So these are the four main components of the axial skeleton. But let's explore further briefly, learn more about them with specific focus on the special features of these bones, the functions they do play, and the various adaptations that they have in mammals. Now, the skull is not always one continuous bone. But if you can see from the illustration given to you here, this illustration provides different colorations to indicate the various different bones making up the skull. Actually, the skull is always made up of about 22 bones. And if you observe it carefully, you'll find areas appearing like as if they're cracks, but they're not actually cracks. These ones are usually um, some fixed joints being referred to as sutures. One is called a suture. So the bones are always joined to each other by some fibrous joints we always refer to as sutures. Take note that in infants, usually, the sutures are always very flexible, and this flexibility is always important to enable the full growth and development of the brain before they can later on harden. I want to believe at some point when you look at an infant, if you look at the head of an infant, you realize at some point you can even tell on the pulse. You're able to tell on the pulse because at that tender age, the bones of the skull have not been fully fused. So these bones are still flexible, and actually they're even able to slightly overlap against each other. Again, this is very, very important, even in the process of parturition or the process of giving birth. Assuming the bones of the skull um, were to harden before the fetus is born, it will be a challenge. But by the time now, when the fetus is being born, these bones are not yet hardened, so they can slightly overlap against each other, and this permits easy passage of the head during childbirth. But of course, also by them slightly overlapping against each other, helps in protecting and minimizing possible damage that can happen to the brain at childbirth. So they always harden with time, and once that is usually at an age where the brain is fully grown and fully developed. At that point now, the bones of the skull harden now to provide a firm protection to the brain and the delicate organs we find there. If you are to look at the skull again further, remember an alternative name for this bones making up the skull is cranium. We can sometimes find us using these two terms interchangeably. Now, at the front end, we always have some two sockets. We always refer to these two sockets as the orbits. And these orbits are important because they are the sockets that house and protect the eye from mechanical damage. And if we are to look at the skull from the underside, we always find some cavity there. We always refer to it as the foramen magnum, and foramen magnum is always very important as it is the passage for spinal cord. If you recall in the previous topic, when you're learning about the central nervous system, you learned that the central nervous system is made up of the brain, and then on the posterior end, there was an extension that was descending lower into the vertebral column, forming the spinal cord. So this foramen magnum provides the passage for the spinal cord to descend lower into the vertebral column. And then again, just closer to the foramen magnum, which I'll illustrate better with this illustration coming forward. We always have some two smooth protuberances or some two smooth protrusions just next to the foramen magnum. These two smooth protrusions are the ones we always refer to as the occipital condyles. And these occipital condyles are important because they are the ones which are going to fit onto the first bone of the vertebral column. So once they fit into that, into those articular facets, those depressions of the first bone of the vertebral column, they end up forming a joint which is going to permit the nodding movement of the head. So it is these two smooth protuberances that the skull is going to use to articulate with the bones of the vertebral column. If we were to look at the various or the significance or the functions of the skull, it is important to know that the bones of the skull are important because they provide surfaces for attachment of muscles. At the same time, they're very important in protection of the delicate organs. The main delicate organs we find being housed and protected by the cranium are the brain, we have the ear, and of course, we are also having the olfactory organs. These ones are the organs specialized for the sense of smell. Then at the same time, these bones are important because they provide support to the organism. What can you say about the adaptations of the skull? Asked to describe the adaptations of the skull, you can say the skull has got orbits, which are cavity for protection of the eyes. We also have the occipital condyles, which are smooth protuberances, as we have discussed, to articulate with the atlas. The atlas is the first bone of the vertebral column. So this articulation forms the joint that links the skull and the vertebral column, and that joint is always very important in enabling us to nod our heads. Then we have also talked about the foramen magnum, which forms the cavity for passage of the spinal cord. And of course, all these bones of the skull, as we have just established, they are fused. This fusion is very important because it enables them to provide firm support. And as you just highlighted, these bones are fused by permanent or rather fixed fibrous joints we are referring to as sutures. And these sutures are also very important in absorbing and dissipating shock. And this enables limitation of mechanical damage that can come as a result of any sort of hard trauma to the head. Other than the skull, the next component of the axial skeleton that you need to review is the rib cage. And as you can see from the illustration that is shown on your screen, this is basically made up of the ribs and the sternum. At the front end of your chest, if you are to place your fingers right at the middle, you'll feel the presence of some hard bone there. That hard bone is this one I'm highlighting here, and we refer to it as the sternum. And then at the back, of course, we are having the vertebral column, this series of short bones running behind there. And then we are having the ribs. The ribs are forming the link between the sternum and the vertebral column. So again, the rib cage is very important in the bones there provide surfaces for attachment of muscles, and also the rib cage is also very important in protection of the delicate organs we find within the thoracic cavity. Talk about the lungs, talk about the heart, the rib cage becomes very important in protection of these delicate organs. As we have just established, the rib cage has got ribs articulating with it. with the sternum at the front and the vertebral column at the back. And the ribs do not attach to the vertebral column and especially the sternum very much directly, but we always have cartilages. You can find we have cartilages at the ends of the ribs here. The ones I'm just cycling here, these ones are cartilages. So the ribs are not always attached to, they are not always attached to the sternum directly. So these cartilages are very important because they minimize they minimize friction, and again they permit some degree of movement, and that is what brings about flexibility of the rib cage. And if you can recall from the previous illustration we are having here, actually, we all have 12 pairs of ribs, meaning in total we are having 24 ribs. And of the 12 pairs of ribs, the 11th and the 12th pair are referred to as the floating ribs. These ribs are floating because if you look at them carefully here, you realize they are not attaching to the sternum at the front. However, in like around 1% of the population, we always have individuals who can always possess the 13th pair of ribs. However, it is important to note that the possession of the 13th pair of ribs is not really offering any advantage. And actually, it's most often it leads to a condition we are referring to as the thoracic outlet syndrome, where the 13th pair of ribs tend to really press against certain nerves and can bring about complications to these individuals. You can read more on that, the thoracic outlet syndrome, and get to know more about the symptoms and the challenges that these individuals always realize. So again, this is a different illustration of this. You can see from here, this is the thoracic vertebra, a type of bone we find in the vertebral column. Then at the front here, we are having the sternum. And then, of course, this one is the rib. This is another rib on this end. And then these ones are cartilages. That's why we are saying the ribs are not attached to, they are not attached to the sternum directly. There is a cartilage in between them, what we always refer to as the costal cartilage. Now, if you can look at the rib further, the rib usually has a long shaft, and this long shaft is important because it provides an increased surface area for attachment of muscles. And then usually the rib also has got structure we are referring to as the tuberculum or the tubercle. And this tubercle is important because it uses it to articulate with the tubercular facet of the thoracic vertebra. Of course, we also have the capitulum, and the capitulum is like the head of the rib here. The tuberculum is this point. This is the capitulum, but this is the tuberculum. So the capitulum is also used to articulate with the capitular demifacet of the thoracic vertebra. Let me illustrate this one just briefly. If we can very quickly try to illustrate this. Here we have the thoracic vertebra. And of course, we are having the sternum at the front here. So one rib, this is how it will be attached to the thoracic vertebra. One rib is always attached to the thoracic vertebra at 2 points, as you can see in this illustration. Of course, there'll be another one on this end, but let me focus on this one only. So at this point, we have a facet, like a plane, a particular surface which this rib is going to attach to at this end. And also on this point also, we have another facet. So if you are to extract the rib alone on this end, this point it uses to attach to this is what we're calling the capitulum. and it always, this is the tuberculum. So a rib is always attached to the thoracic vertebra at 2 points. It uses the tuberculum. Now the surface, the facet, again, still on this in a sketchy way though. So if I bring this again, here we have a facet, and also here we have a facet. The facets are planar surfaces which bones use to articulate with other bones adjacent to it. And the term articulate, we will be using it largely to refer to joining. If I say this bone is articulating with this bone, I simply mean this bone is joined to this other bone at that point. So this is the part we are calling capitular demifacet. And this is the part we are referring to as tubercular facet. We will learn later that actually one thoracic vertebra has got one tubercular facet, but it has got two capitular demifacets. So if we were to ask you for the adaptations of the ribs, those are the main features you can highlight. A long shaft to increase surface area for attachment of muscles. The fact that the ribs have got tubercular to articulate with the tubercular facet of the thoracic vertebra, and the presence of the capitulum again to articulate with the capitular demifacet of the thoracic vertebra. That said, at the front end, as I indicated earlier, if you are to hold the front end of your chest there, you'll be feeling a presence of a hard bony structure there. The one I'm just highlighting here. This one forms the sternum bone. So the sternum together with the ribs that is making up the rib cage are very important in protecting the delicate thoracic organs. They are also the sternum also is important in supporting the ribs, and of course it also provides surface for muscle attachment in the organisms that possess it. The sternum in some mammals, and actually in a good number of mammals, the sternum is always not that well developed. But if you look at the birds, the sternum is always very much pronounced. The structure I'm highlighting here is actually a prominent sternum. We call it the keel, but the keel is simply a very prominent sternum. And why is it very prominent? Why is it very much well developed in the birds? The birds always rely a lot on the flight muscles for their locomotion. So this prominent development of the sternum to form the keel provides a large surface area for attachment of the pectoral muscles. The pectoral muscles are the muscles which the birds often use to enhance their locomotion. So what are the key takeaways for this video? There's need for you to be able to describe the skeleton systems in mammals, the axial skeleton, which bones form the axial skeleton, the appendicular skeleton, which bones form the appendicular skeleton, and again, the features and the functions and adaptations of the skull, very important. What are the roles of the skull? What are the various adaptations? What are the features, the orbits, the occipital condyles, the sutures, the structure, the functions and adaptations of the rib cage? What are the roles that the rib cage plays in mammals? And particularly the structure of the rib and its adaptations is also very important. And of course, finally, the structure and the functions of the sternum. Thank you so much for staying with me through this lesson. Till the next, bye-bye.